Hey guys, I'm Jose and this is tutorial number 5 on functions. Okay, so let's start right in. We're going to learn how to define your own functions, and this is a really good way of keeping your code tidy and optimizing what the amount of code you write. Like anything that you see yourself writing twice, you can make it into a function that would just you can call with a shortcut somehow, right? So let's see how to define something like a function, right? So the first thing you need to define a function is use the keywords def, D-E-F, as describing define, and we're gonna say my function, right? My function. So we're gonna do something very simple first, and we're gonna open parentheses, and we're gonna put the inputs of the function. In this case, I'm gonna put x and y, right? And column. So now the this indented space would be similar to the for loop. Everything that it's in this indented space would be the statements inside the function, right? So we're gonna say something like print x plus y. Extremely simple. So we're using the inputs of x and y, and we're using those inside the function, right? So those inputs are visible inside the function. Now, if we just go out of the function, so let's say, oops, we're gonna right here, we're gonna call the function, right? So we're gonna say my function. And we're going to put something like 10, 8. And let's see. Sorry, this is just function. Right, there we go. So you can see that my function is actually calling this method here, right? It's calling the addition, so we could copy paste this line and then call our function with different values. Right? So we're calling the function with different values, and we're kind of all the time just using different inputs for this operation, right? So let's see, and you can see that the different additions and the prints appear on the screen. So, I mean, the addition is pretty much inbuilt, so you might ask yourself, like, why do we need to just do an addition function, right? So, yeah, true, we don't really need to do something like that. Let's do something a little bit more interesting. We're going to introduce how to use elements on the screen as well. So this is quite exciting because you could start seeing how you could actually start building some geometry out of modeling or drawing stuff, and you could incorporate some of the procedures with scripts, right? So let's do something like str object, right? And we're gonna say equals rhino dot get object, right? So this function allows us to collect something from the screen, from the workspace. So we're going to open parentheses here, and we're getting a little bit of help here. And it says, first of all, you need to provide a message. Right? Okay, so we're going to say, as in a string, we're going to say pick an object from screen, right? And then it suggests that we put a filter on. So if you don't really know what this means, we could just always press F1 and go to the help file. So let's say get object, right? So get object has a lot of information here, and the filter type, it's a value that depending on the value that we use, it's a filter in which you will only be allowed to select certain kinds of geometry, right? So if we put 0, we will be able to select anything. If we just put a 1, we will only be able to select points. In this case, I want to just be able to select curves, so I'm just going to put a 4 here, right? And you can see that this function actually returns the identifier of an object. So what you're seeing here is string object, a variable, and equal. Because this function returns an object, this variable would get assigned the identifier of that object, right? So this is an operation that we'll be using a lot to use variables that that contains the identifier of objects, right? So let's put also for, that is the filter for curves. And I'm going to close it. There's a lot of other parameters that we could actually use, so just feel free to go and check those. If you want to just add more arguments to this function, you would just put comma and more stuff here, but you can just leave it like that and that will be fine. So let's go ahead and just build some piece of like some curves. And here I'm just gonna draw a circle, right? That's fairly simple, like a curve, something on screen, right? So if we run this now, you can see here that the command line is asking us pick an object from the screen, and if we go inside the workspace, we can actually click on that object and we actually select it. So the script is actually allowing us, it starts running, it asks for an object to pick from the screen, and we can do something with that. We're not doing anything right now, but we will, right? So let's change this function right now. Let's remove this and let's change this. My function would receive an object and a translation, right? So we're gonna, inside the function, we're gonna call rs.move object, right? So as any Rhino function, this will ask us for some information. It says I require an object ID and a translation, right? So we could go into F1 and check how to work with this, but I actually know how to do it. So we need to provide the string identifier of an object, that this is what this function is actually returning, right? So let's put object, and we are gonna put the translation here, right? So these are the two arguments that this function needs. So when we call this function, we will need to provide a string identifier of an object, and in this case it's a translation. A translation is a little list that contains 3 values, x, y, z. So let's see how to call that function now. We need to first define our function, and after that we are gonna call it, right? So if we do it the other way around, like in other different programming languages, that wouldn't work because it would ask us I don't know what that function is, right? So let's call that function. So my function, right? And I'm gonna put str object as the object identifier. That's the first argument that this function is asking for, right? And then I need to provide a list. Again, if you are not familiar with lists, we'll do a tutorial on lists specifically and how to build those, but it's a little collection of numbers. So we're gonna say 20, 0, 0, right? So, and then we need to close the parentheses. Just make sure that your parentheses are, you can see that everything seems to be fine, right? So we're providing an object and we are moving it in this amount of units. At the same time, I want to say something like print translation successful. I don't know if you spell it like that, that's right. So we're doing not just one thing, but we could put as much as we want here. We can do functions that are quite long, but it's good to keep them short. And now our function will execute this line. Let's see. So pick an object from the screen, click, and the function gets executed, and it displaces our element in 20 units, right? Right. So can we call this function twice, right? Well, yes, let's try it again. So maybe we could just wanna use maybe my function, the same object, we're going to use the same object. In this case, we're going to say 10 units in X, and then maybe 10 units in Y. We could, obviously, we could just put 10 and 10 and it would be the same result, but I just want to show how we are kind of calling the function with different arguments, and that will actually produce this result. It was moved 10 units to the right, and then the same object got moved 10 units in Y. So that is how do we define a function. And also we saw how to get an object from the string. The last thing I wanted to do here maybe is to show a little bit of what's going on behind the scenes of what is this string identifier, right? So let's print string object. And when we pick this element, we can see this long number here, right? So this is the way in which Rhino identifies each element in the scene. Each object that you have, anything that you actually draw, will have a specific identifier that is a string, a very long string. Right? It's not that you will ever have to type this information in. It's only that you want to collect that information and be able to do stuff with it, this object. In this way, the script will know that we're referring to that object and that we want to do operations with it. So bearing that in mind, how to return variables from a function, inbuilt function of Rhino, and how to build our own functions to actually automate some procedures. The next tutorial, we're going to be looking at classes, and that would be the end of the first chapter. And then we're going to really dive in some of the geometric operations that we can do with Rhino Python.